This is a video from the Exam 4 review. Let's take a look at problem 4. Suppose we have the summation from n equal 2 to infinity of x plus 2 to the n divided by 2 to the n times natural log of n. We want to look for the interval and radius of convergence. So to do that, we're going to apply the ratio test. So we get the limit as n goes to infinity of the absolute value of x plus 2 to the n plus 1 divided by 2 to the n plus 1 natural log of n plus 1 times 2 to the n natural log of n divided by x plus 2 to the n. So this can be written as the limit as n goes to infinity of. Now we get the absolute value of x plus 2 to the n times x plus 2 divided by 2 to the n times 2 times natural log of n plus 1 times, now in the numerator we get 2 to the n times natural log of n, and in the denominator we get x plus 2 to the n. And so here, the x plus 2 to the n's cancel, the 2 to the n's cancel, right? And then here we get the limit as n goes to infinity of the absolute value of natural log of n divided by natural log of n plus 1 times x plus 2 divided by 2. But as n goes to infinity, natural log of n over natural log of n plus 1 is going to go to 1. And so what we have left is x plus 2 divided by 2. This series converges when the absolute value of x plus 2 divided by 2 is less than 1. If the absolute value of x plus 2 over 2 is less than 1, then the absolute value of x plus 2 is less than 2 if you just multiply both sides by 2. And so, therefore, negative 2 is less than x plus 2, which is less than 2 if we unwind that absolute value. And so, therefore, x is less than 0 and greater than negative 4. We still got to test our endpoints. So I'm going to plug in x equals 0. And so this is the summation from n equal 1, this is the summation from n equal 2 to infinity of 1 over natural log of n. Okay, now, here's what we got to keep in mind. For n greater than or equal to 2, I claim that natural log of n is less than n. And so that implies 1 over natural log of n is greater than 1 over n. Now, what does that mean? Well, this series diverges by the comparison test. Because if you notice, I compared 1 over the natural log of n, that series, to a harmonic series. Okay? So I would make sure you're convinced of that. Make sure that that makes sense. Now, for x equal negative 4, right, we get the summation from n equal 2 to infinity of negative 1 to the n divided by natural log of n. And this series converges. By the alternating series test. So what does that mean? My interval is negative 4 closed to 0 open. My radius of convergence is 2. So that's how number 4 works. Same directions on number 5. Suppose we have the summation from n equal 1 to infinity of x to the n divided by, and you get 1 times 3 times 5 all the way through until 2n minus 1. Okay? And again, we're going to, let me write that. We're going to apply the ratio test here. So I'm going to get the limit as n goes to infinity of, I'm going to get the absolute value of x to the n plus 1. So wherever I see an n, I pop an n plus 1 in its place. And I'm going to divide by 1 times 3 times 5 all the way through until, and then I get 2 times n plus 1 minus 1. Okay? So wherever I see an n, replace it with n plus 1. Then I'm going to go times 1 times 3 times 5 all the way through until 2n minus 1 divided by x to the n. And so this is the limit as n goes to infinity of, in absolute value, I get x to the n times x divided by 1 times 3 times 5 all the way through until, now if I distribute the 2, I get 2n plus 2 minus 1, which is 2n plus 1. And then I multiply by 1 times 3 times 5 all the way through until 2n minus 1 divided by x to the n. Now, if it helps to make this make sense, I would suggest to put the factor in before 2n plus 1. Okay? We already know the x to the n's are going to cancel. And so over here, I'm going to get the limit as n goes to infinity of the absolute value of x times 1 times 3 times 5 all the way through until 2n minus 1 divided by. And then on the bottom, I get 1 times 3 times 5 times all the way through until 2n plus 1. What I'm saying is input the factor that comes right before 2n plus 1. And the one that comes right before 2n plus 1 is 2n minus 1 if we follow the pattern. But look what happens. These factors will kill off the factors down here. And what we have is the limit as n goes to infinity of the absolute value of x divided by 2n plus 1. That's 0, which is less than 1 for all x. What does that mean? My interval of convergence is going to be negative infinity to infinity. It didn't matter what that x was. I'm going to get 0 no matter what that is. So the interval is negative infinity to infinity, and my radius of convergence we would just write as infinity. And that's how you do problem number 5. Let's take a look at 6. So if I have f of x is equal to x over 1 plus 4x squared, and I want to represent this function as a power series. So the question is, what do I do? Okay. Now, we already know that 1 over 1 plus x is the summation from n equals 0 to infinity of negative 1 to the n x to the n. We know that, right? Now, what I would do is I would take the derivative. When I take the derivative, I get negative 1 over 1 plus x to the second is the summation from n equals 0 to well, actually, before I'm too quick, right? When I take the derivative, notice that that lower limit has to become a 1. So I get the summation from n equal 1 to infinity, right? And it's negative 1 to the n times nx raised to the n minus 1. Okay, from here, replace x with 4x. And so I get negative 1 over 1 plus 4x to the second is the summation from n equal 1 to infinity of negative 1 to the n times 4x to the n minus 1. Now, before we go much further than this, I would use the law of exponents to split that off, right? And so here I get negative 1 over 1 plus 4x to the second is the summation from n equal 1 to infinity of, I'm going to get negative 1 to the n times n times 4 to the n minus 1 times x to the n minus 1. So if we can, divide through by negative 1. So I get 1 over 1 plus 4x to the second is the summation from n equals 1 to infinity of negative 1 to the n minus 1 times n times 4 to the n minus 1 times x to the n minus 1. And if I multiply through by x, I'm done. So x over 1 plus 4x squared is the summation from n equals 1 to infinity of negative 1 to the n minus 1 times n times 4 to the n minus 1 times x raised to the nth power. The question is, what is the radius of convergence? Now, what if I apply the ratio test? Now, I'm only asking for the radius of convergence. I'm not asking for the interval. So once we apply the ratio test, this should tell me what that radius of convergence is. So I'm going to look at the limit as n goes to infinity of the absolute value of negative 1 to the n times n plus 1 times 4 to the n times x to the n plus 1 divided by, then I'm going to get negative 1 to the n minus 1 times n times 4 to the n minus 1 times x to the n. Okay? As n goes to infinity, if I look at n over n plus 1, this is going to go to 1. Okay? And so what we have left is 4 times the absolute value of x. Now, this series converges when 4 times the absolute value of x is less than 1. And so, therefore, it converges when the absolute value of x is less than 1/4. So if you notice, this right here is going to be my radius of convergence. So r is going to equal 1/4. And that's how we do problem number 6. Let's take a look at problem 8. Suppose we have f of x is equal to x squared arctangent of x cubed. And we want a power series. Now, if we can, right, arctangent of x is the summation from n equals 0 to infinity of negative 1 to the n times x to the 2n plus 1 divided by 2n plus 1. Okay? Now, what I'm going to do is replace x with x cubed. And so arctangent of x cubed is the summation from n equals 0 to infinity of negative 1 to the n times, and then I get x cubed to the 2n plus 1 divided by 2n plus 1. Now, if we come up here, isn't 3 times 2n plus 1 6n plus 3? And so this is the summation from n equals 0 to infinity of negative 1 to the n times x to the 6n plus 3 divided by 2n plus 1. Now what I get to do is multiply both sides by x squared. So x squared arctangent of x cubed is the summation from n equals 0 to infinity of negative 1 to the n times x to the 6n plus 5. So again, 6n plus 3 plus 2 is 6n plus 5. And then I just divide by 2n plus 1. And that's how we do problem number 8. And then I would actually ask you, what's my radius of convergence? And are you convinced of what that is? So, and I would check, is the radius of convergence for this power series 1? I would want to know if we're comfortable with that. Let's take a look at 9. On number 9, we want to integrate arctangent x divided by x dx. And we want to do this as a power series. Now, arctangent x is the summation from n equals 0 to infinity of x to the 2n plus 1. Well, let me put in that alternating part first. We get negative 1 to the n x to the 2n plus 1 divided by 2n plus 1. Okay? And so arctangent x divided by x is the summation from n equals 0 to infinity of negative 1 to the n x to the 2n, right, divided by 2n plus 1. So when I divide by x to the 2n plus 1 went down a step. And so this is the integral of the summation from n equals 0 to infinity of negative 1 to the n x to the 2n divided by 2n plus 1. Okay. Now let's go to the next page. So we have the summation from n equals 0 to infinity of negative 1 to the n x to the 2n divided by 2n plus 1 dx. There should be a dx here. Now, on its interval of convergence, I can move that integral into the sum, right? It only makes sense for the values of x for which the series converges. That is one thing I want to make sure we understand. And so when we're done, we get c plus, c is my constant of integration, and it's the summation from n equals 0 to infinity of negative 1 to the n x to the 2n plus 1 divided by 2n plus 1 raised to the second. And that'll do it for this video. And in this video, we looked at problems 4, 5, 6, 8, and 9. Yes. Thank you very much. And, oh, what's my radius of convergence? I claim the radius of convergence should be 1. Again, make sure you're convinced. Okay, thank you.